Each domain name used for forwarding on a DNS server is associated with the IP addresses of one or more DNS servers. A DNS server configured for forwarding will use its forwarders list after it has determined that it cannot resolve a query using its authoritative data. If the server cannot resolve a query using the forwarders, it may attempt them for recursion to the root hint servers. Let's talk now about DNS zones. A DNS zone can hold the resource records for one domain, or it can hold the resource records for multiple domains. A zone can host more than one domain only if the domains are contiguous, that's it, connected by direct parent-child relationship. One reason to divide a namespace into zones is to delegate authority for different portions of it, as one very large domain could be difficult to administer if contained in one single zone. For each DNS domain name included in a zone, the zone becomes authoritative source for information about that domain. When a zone is authoritative over a portion of the namespace, it means that it hosts the resource records for that portion of the namespace. It does not necessarily mean, however, that the server can update or modify that zone. DNS zones are classified by where they are stored, whether they are writable, and by what information they receive and return. Zones can be stored either in text file or in Active Directory. When you configure a DNS server, you can configure it either with several zones types or with none at all. Depending on the type of the role that the DNS server has in the network, you can configure these two options. By using different zones, you can configure your DNS resolutions or solution to best meet your needs. For example, it is recommended that you configure a primary zone and a secondary zone on separate DNS servers to provide fault tolerance if one server fails. You can also configure a stop zone, which is the zone that is maintained on a separate DNS server to allow local DNS servers to stay up to date whenever remote DNS server information for a particular zone is updated. In brief, zone data is maintained on a DNS name server and is stored in one of two ways: as a text-based zone file containing lists of mappings called standard zone or a file back zone, or within an Active Directory database called an Active Directory integrated zone. In terms of the types of query that a DNS zone, either standard or AD integrated, can respond to, each zone can be either forward lookup zone or a reverse lookup zone. In turn, each forward or reverse lookup zone can be one of the three types: primary, secondary, or stop. As you can see, there are numerous possible combinations of each zone type that you can configure on a DNS server. For example, a single DNS server can host a standard primary forward lookup zone, a standard secondary forward lookup zone, an Active Directory integrated stop zone, a standard secondary reverse lookup zone, and so on. When configure a DNS server, you can configure a single server to host multiple zones if desired, and you can mix and match between different zones types. For example, a single DNS server might host a primary zone for contoso.com, as well as a secondary zone for Microsoft.com, to allow improved name resolution for a remote network's resources, as might be necessary in the case of cross-department or cross-organizational projects that require access to the resources across multiple organizations. You can configure DNS zones in a number of different ways to meet the requirements of your network topology, administration model, and the size of your DNS namespace. Typical DNS server operation involve three standard zones: primary, secondary, and in ADDR RPA. Windows Server 2003 and Windows Server 2008 provide a fourth option, that is the stop zones. Let's look at each of the standard zone styles that you can configure in Windows Server 2008. First, we have the standard primary DNS zone. A primary zone hosts a read-write copy of the DNS zone in which resource records are created and managed. Only one server can host and load the master copy of that zone. No additional primary servers for that zone are permitted, and only the server hosting the primary zone is allowed to accept dynamic updates and process zone changes. When setting up the DNS servers to host the zones for a domain, the primary server normally is located where it will be accessible for administering the zone file. Then we have the secondary zone. A copy of the zone file may be stored on one or more servers to balance network load, provide fault tolerance, or avoid forcing queries across a slow wide area network link. This standard secondary zone is a read-only copy of the standard primary DNS zone. In standard zones, information from a primary zone is transmitted to a secondary zone by performing a zone transfer, which is done by copying the zone file from primary server to a secondary server. A zone transfer can be a full zone transfer, in which the entire content of the zone is copied from the primary server to the secondary server during each zone transfer. Or it could be an incremental zone transfer, in which only change information is transmitted after the initial full zone transfer, in order to cut down on the bandwidth usage between the primary zone that is holding the DNS server and the secondary server. When a secondary zone is created, you must specify the IP address of one or more master DNS server from which you want to copy the zone. This can be the primary DNS server for the zone or another secondary DNS server. These copies are referred as a secondary zone data files. The secondary zone database files are updated regularly from the primary zone database. And finally, we have the stop zone. A DNS server running Windows Server 2003 or Windows Server 2008 also support a new type of zone called the stop zone. A stop zone is a copy of a zone that contains only those resources records necessary to identify the authoritative DNS servers for that zone. A stop zone is a pointer to the DNS server that is authoritative for that zone, and it is used to maintain or improve DNS resolution efficiency. The stop zone contains a subset of zone data consisting of a SOA, an NS, and an A record. Don't worry, we're going to explain these records later in this lesson. Like a standard secondary zone, resource record in the stop zone cannot be modified. They must be modified at the primary zone. Stop zones enable a DNS server to resolve the DNS queries by using a stop zones list of named servers without needing to query the internet or internal root servers for the DNS namespace. Using a stop zone throughout your DNS infrastructure enables you to distribute a list of unauthoritative DNS servers for a zone without using the secondary zones. However, stop zones do not serve the same purpose as secondary zones and should not be considered as a solution to address redundancy and load sharing. DNS zones can perform two types of name resolution in two directions: forward lookups and reverse lookups. Forward lookup DNS zones allows DNS clients to resolve a fully qualified domain name to an IP address. These ones are the most commonly used DNS records on the internet and within private networks using DNS for name resolution. You must first create a forward lookup zone to hold the records, and next, you can create the records needed for the resolution. On the other hand, we have the reverse lookup zone. which perform the opposite action of the forward lookup zone. It maps IP addresses to host names. The reverse lookup zones are less commonly used. Uses for reverse lookup zones include the verification of an SMTP server name. After a reverse lookup zone is created, pointer records, or PTR, are created to map IP addresses to host names. These records can be created manually through the DNS console or from the command line. Or you can have the record created automatically when a forward lookup record or an A record is created. Remember that the A record or the 4A record are the ones that are used for the forward lookup zone.